By the end of this lecture, learners will be able to discover the importance of Bloom's taxonomy in the educational field. Explore the 6 levels of Bloom's framework for effective learning objectives. Identify the aims and objectives that drive Bloom's taxonomy. Describe the process of implementing Bloom's taxonomy in teaching. Hello everyone and welcome. This lecture discusses the importance of Bloom's taxonomy and its impact on higher order learning skills. It focuses on the aims and objectives of this taxonomy to develop a teaching learning experience that encourage critical analysis and enables high-quality learning outcomes. So, let's begin with this question. How does Bloom's taxonomy help teachers plan and deliver engaging and impactful content? Bloom's taxonomy is a classification system that arranges learning objectives into a hierarchy based on the level of cognitive complexity involved. Developed in 1956 by a group of educational psychologists led by Benjamin Bloom, this influential framework has become a cornerstone of effective teaching and learning. Bloom's taxonomy consists of 6 levels: remembering, understanding, applying, analyzing, evaluating, and creating. These levels represent a progression from lower-order thinking skills, such as recalling facts and concepts, to higher-order skills, such as critically appraising information and generating novel ideas. The taxonomy provides a common language for teachers to articulate learning goals, design instructional strategies, and assess students' performance. By aligning these elements with the appropriate level of Bloom's taxonomy, teachers can ensure that learners are actively engaged in the learning process and developing a range of essential cognitive abilities. The importance of Bloom's taxonomy. Bloom's taxonomy is a seminal framework that has profoundly shaped the field of education. This influential taxonomy offers a powerful lens through which we can understand and design learning experiences that foster a range of cognitive skills, from basic recall to higher-order critical thinking. Bloom's taxonomy provides teachers with a roadmap for crafting learning objectives, aligning instructional strategies, and developing meaningful assessments. Here are some key reasons why Bloom's taxonomy is so important. 1. Clear learning objectives. Bloom's taxonomy provides a clear and structured way to define learning objectives, ensuring that they are specific, measurable, and aligned with the desired learning outcomes. 2. Cognitive development. By progressing through the levels of Bloom's taxonomy, students develop a deeper understanding of the subject matter and improve their cognitive abilities, including critical thinking, problem-solving, and creativity. 3. Effective instruction. Bloom's taxonomy helps teachers design instruction that is engaging, relevant, and challenging, ensuring that students are actively involved in the learning process. 4. Assessment alignment. The taxonomy provides a framework for developing assessments that are aligned with the learning objectives, ensuring that students are evaluated based on their understanding and application of the material. 5. Transfer of learning. By focusing on higher-order thinking skills, Bloom's taxonomy helps students develop the ability to apply their knowledge and skills in new and complex situations, enhancing their transferable learning. What are the 6 levels of Bloom's taxonomy? Bloom's taxonomy is a classification system that arranges learning objectives into 6 hierarchical levels, each representing a different cognitive skill. These levels, from lower order to higher order thinking, include 1. Remembering. Recalling and retrieving knowledge from long-term memory. This level involves activities like memorization or simple fact recall. 2. Understanding. Comprehending and synthesizing information through interpretation, classification, inference, or explanation. This level includes activities like summarizing, reframing, or explaining information in one's own words. 3. Applying. Using learned information in a new situation or context. This level involves solving problems and completing tasks independently. 4. Analyzing. breaking down the material into its constituent parts and determining how the parts relate to one another and to the whole. This level includes activities like differentiating, distinguishing, and comparing. 5. Evaluating. Making judgments about the value of ideas or materials based on established criteria. This level involves activities like critiquing, judging, and selecting. 6. Creating. Putting elements together to form a new whole or reorganizing elements into a new pattern or structure. This level includes activities like inventing, designing, and composing new ideas or products. Applying Bloom's taxonomy. Bloom's taxonomy provides a valuable framework for designing learning experiences that support a range of cognitive skills. Teachers can intentionally structure lessons, activities, and assessments to target different levels of thinking. Design effective learning experiences include 1. Learning objective formulation. Teachers can use the taxonomy to write clear, specific, and measurable learning objectives that target different levels of cognitive complexity. By aligning objectives with the appropriate level of Bloom's taxonomy, teachers use action verbs, for example, define, explain, apply, analyze, evaluate, design, and ensure they are specific and measurable. 2. Instructional strategies. The taxonomy can guide the selection and implementation of instructional strategies that align with the desired learning objectives. For example, lower-level objectives may require more direct instruction and practice, while higher-level objectives may benefit from active learning strategies, such as problem-based learning or case studies. 3. Assessment design. Bloom's taxonomy provides a framework for developing assessments that evaluate student learning at different levels of complexity. By incorporating a variety of assessment methods, such as multiple-choice questions, essays, projects, and presentations, teachers can gain a more comprehensive understanding of student learning and identify areas for improvement. 4. Curriculum development. The taxonomy can inform the development and sequencing of curriculum content, ensuring that students are exposed to a range of learning experiences that build upon one another and challenge them to progress through the levels of cognitive complexity. 5. Professional development. Bloom's taxonomy can be used as a tool for professional development, helping teachers reflect on their teaching practices and identify areas for growth. By aligning their instruction with the taxonomy, teachers can ensure that they are providing students with engaging and effective learning experiences. Limitations of Bloom's taxonomy. While Bloom's taxonomy has been a cornerstone of educational practice for decades, offering a structured framework for designing learning objectives and assessments, it also has some limitations. 1. Rigid hierarchy. Bloom's taxonomy is often depicted as a rigid hierarchy, which can lead to a linear and inflexible approach to learning. This may not account for the complex and dynamic nature of learning, as the levels are not always strictly linear and may overlap or interact in unexpected ways. 2. Overemphasis on cognitive domain. The cognitive domain is often prioritized over the affective and psychomotor domains, which can lead to a neglect of important aspects of learning and development. This narrow focus on intellectual skills may fail to capture the holistic nature of the learning process. 3. Difficulty in implementation. Implementing Bloom's taxonomy can be challenging, especially in complex educational settings, due to the need for clear and consistent application across all domains. Teachers may struggle to accurately categorize learning objectives or assessments within the taxonomy, leading to inconsistencies and misalignments. 4. Lack of consideration for individual differences. Bloom's taxonomy does not explicitly account for individual differences in learning styles, preferences, or abilities. It assumes a one-size-fits-all approach to learning, which may not be effective for all students. Despite these limitations, Bloom's taxonomy remains a valuable framework for designing effective learning experiences and fostering a range of cognitive, affective, and psychomotor skills in students. However, It is essential for teachers to recognize its limitations and adapt it to their specific contexts and learner needs. Conclusion. Bloom's taxonomy has profoundly influenced educational theory and practice since its inception. It stands as a pivotal model that has significantly influenced educational practices. By categorizing learning objectives into distinct levels, it provides teachers with a clear framework to design curricula, instructional strategies, and assessments that promote higher-order thinking skills. It offers a powerful framework to understand and design learning experiences that foster a range of cognitive, affective, and psychomotor skills. Bloom's taxonomy has a wide range of applications in education, serving as a powerful tool for designing effective learning experiences and assessments. Despite some criticisms regarding its rigidity and potential oversimplification, Bloom's taxonomy remains an invaluable resource for fostering critical and creative thinking. As technology integrates further into education, and interdisciplinary approaches become more prevalent, the taxonomy's adaptability ensures it will continue to be a cornerstone of effective teaching and learning. It challenges us to strive for deeper understanding, thoughtful application, and innovative creation, paving the way for a future where learning is both dynamic and transformative.